Hi, I'm Professor Lewis from UCL and the NCEO in the UK. I'm just going to give a bit of information about our work on crop monitoring and mapping with our colleagues at CAU, CAS, and WHO in China, and more recently with colleagues in Ghana as well. The aim of our work is monitoring and yield information systems, building these things, and we've been collaborating on this for a number of years, and we've developed software and initial methods, and we have initial results. Most of the work that we've done so far has been based around the North China Plain, around winter wheat, and broadly the system that we're talking about involves building 10-20 meter yield maps and predictions of yield, driven by crop model, WOFOS in this particular case, modeling, and with a data assimilation system based around information from Sentinel-2 biophysical parameter extraction. We use an ensemble data assimilation system for that. We've tested over the North China Plain with data sets collected in recent years in Hebei province by our Chinese colleagues. And what we've achieved is demonstration of the local mapping of yield and demonstration of the reduction in uncertainty on the yield from the model predictions. We have some validation, but it's limited by limited validation data sets that we've been able to use so far. This is an overview of the system. Step one is that you have a distribution of model parameters that covers the state. You then have you then run the model over some specific location with particular weather drivers, and that allows you to predict model state. So leap area index development or whatever else it might be that you're linking to your observations, and also other model outputs, evapotranspiration, and ultimately yield. So the prior model, just running the model, gives you a distribution of biophysical parameter development and yield and other terms. We then confront those an ensemble set of those with observations or derived information from leaf area index for some specific location, and that produces a posterior estimate of the crop parameter, and then from that you can derive a posterior estimate of the yield. So this is an animation showing the data assimilation working for one pixel along with other parameters of interest. So the green outputs are the model results, and the main effect on the model is confronting the trajectories of modeled LAI with observations. So we collapse that set, which then has the impact of reducing the yield uncertainty predictions. It weights, if you like, each member of the ensemble, and that gives us an update on the predicted yield. It obviously also affects other outputs from the model, which we can see in the other model outputs. So the result of that data assimilation is the within field wheat yield estimation at 10 or 20 meter spatial resolution, and we're rolling this out now for the Sentinel-2 era over the North China Plain. So the extensions of the work are that we're putting more effort into the prior calibration. So we only had a limited data set to achieve the a priori model calibrations. So we're now extending that with wider data sets on wheat and on maize, and also linking it through to multi-models, where, as I mentioned, there's these other linkages to biophysical parameters that we want to express in the linkages to the model. And then practically we're extending this out to wheat and to maize in the work that we're doing, and moving our work from just based in China and the UK to extending collaborations to Ghana as well. So I'm new to having this involvement in GeoGlam, and I'm looking forward to understanding more about what we can do to contribute to the global activities in this area. And I hope this gives some flavour of the sort of things that we're following at the moment. Thank you.